Hello and welcome to Func Prog Sweden. We are back, and this is the 8th Func Prog this year. However, we're in the 9th month, so we have just missed out one meetup in July because it's summer in Sweden. So over to today's agenda then. Me, Magnus Edlasek, I'll do a short intro. And then we'll have a functional programming from a theorist perspective by Rhea. And then for those of you who missed it, now you know it. We had a contest where you could win tickets to the F-Sharp Exchange conference by Skills Matter in October. So we'll announce the winners then. And then after that, we'll head over to Marcus and his presentation, Changing to Closure Mid-Flight. And in the end, I'll do a summary, schedule and summary of this meetup. First up, I would like to thank our video sponsor, Otherbeat. Otherbeat is a small IT consultancy company in Stockholm, where most of the developers have a background in functional programming. If you want to know more about Otherbeat, check them out in social media or on the web at otherbeat.com. Also, if you want to support Func Prog Sweden, join the meetup community, and please follow our YouTube channel, Func Prog Sweden, and check out. Also, you can check out the store. We put up like a merchandise store, so you can check it out, and you'll find the link in the description. If you have questions during the presentations, please put them in the chat, and I will read them out to the presenters. With that said, let's start. First presenter, Rhea. Welcome to Func Prog Sweden.
Without further ado, so basically this talk will be a very general talk on functional programming. It will be more of a top-down approach than a bottom-up. So the difference from my talk to most of my predecessors is that most other people have basically worked on actual projects. I haven't, but I have the advantage that I come from academia and I've got a bit of a more theoretical, mathematical background, which means I can maybe explain functional programming in more conceptual terms. Don't be scared, I won't show much code in this. I also won't show any maths though. So what I aim for is that you really understand the concept behind it at the end of the day, and maybe learn some tidbits that you can use in your daily developer's life. For example, when you're coding yourself, you don't need to be a full-blown functional programmer, but if you learn a few things here and there, I found in my experience that it can really help. So let's get started. This is what I'm going to do in this talk. So basically, from my side, because people like talking about themselves, but also because you might like to know who I am, how I became somewhat of a functional programmer sometimes, and then what functional programming is from a conceptual point of view, and how it is really quite an opposite to object-oriented programming. Then also some advantages, key features, different programming languages, and maybe also some limitations. If you find that the whole sequence of chapters, let's say, in this talk is a little bit jumbled, that's on purpose because I want to keep you engaged and entertained. And it would be stupid for me to go step by step and just, talk something boring. So sometimes things will be a little bit changed up. Okay, so about myself. I'm a particle physicist. At the moment, I'm doing my PhD actually in Paris. And how I got there was in high school. I just thought, I loved maths, but I thought I might be too dumb to actually be able to study maths. So I decided to study physics instead because that seemed like the next best option. I think it was the right decision for the wrong reasons looking back. And regarding what I ended up doing, which is a lot of programming actually in computer science. At that point in time, I thought, you know, computer science is for nerds, and I'm not a nerd. So I did what not nerds do and studied physics. So I went to Heidelberg, which is in Germany, and studied physics there, which I enjoyed. I also went to CERN, which is a big particles accelerator in Geneva, and had some nice experiences there. And then I went back to Heidelberg to work on my bachelor thesis. By that time, I realized that I wanted to stay in particle physics, which is what this lab CERN is also focused on. But I wanted to go to theoretical physics and not the experiments where you build detectors and things like that, which was fun. But I really wanted to learn what the theory behind it all was. And so I started working with data and trying to match this experimental data, physics data, to physics models, physics theories. At first that was quite overwhelming, but I got used to it and I started liking it quite a lot, so much so that I ended up now in Paris working on my PhD and basically still doing the same thing, which is kind of trying to sift through experimental data and understanding it in such a way that where it can make sense and build a physics theory from this. And it was during last year or so that I was working a lot on a blog, which I do on the side on Medium, where I write about data science and things like that. Makes sense. And I realized, oh, functional programming exists and it's actually quite cool. And it's right up my street because it works with lots of data and it has some mathematical proofs in it. And me with a strong mathematical background, I was like, yay, that's cool. So I dug into that and wrote an article about that. And this article was successful, and Magnus contacted me on Twitter, and I took like 2 months to reply to him because I'm lazy and I don't look on my Twitter, but I eventually did. And so that's how I ended up here. So that's why I'm here today. And what I'm hoping is that you'll like this too. I guess you do because you're here today. And I hope that you can also take away some things from this and understand functional programming also a little more from a conceptual point of view. So that being said, all about me, what is functional programming as such? Or we could ask, what do functional programmers want? Well, at the beginning, actually, what they wanted to do is to write computer programs which were mathematically provable. So it is actually software that is correct anytime. If you've been in software before, you probably know that you write a code and it never behaves the way you think it does. And so you test it to death and you test all edge cases you can think of, and then you deploy it, and then something goes wrong again, which you didn't test for. And in functional programming, this can't really happen because as soon as you write this program, you know it's correct. You don't need to test any edge cases, you know it. And that is really the aim of functional programming. That's ambitious. And the question is, how do you manage that? It turns out that there's a very simple trick in a way, which is separating the, how do they do that? Which is separating the theory, so the data, the manipulations of data, so the function of the data itself. In other words, transformations of data, which is functions. I'm separating that from the definition of data. And that leads to some very remarkable consequences, because it enables you to test your programs better, because you know it's correct. You just have to test one case, and then you know for every other case it's right. You can prove that is correct, you kind of know, but you can also prove it in a mathematical proof. in practice, this is not done very much because these proofs are lengthy and hard to understand. But the important part is that you know that is true and that you could, in principle, prove it. And because they're so neat, basically, and true all the time, it's much easier to build and scale enormous projects because you don't rack up the type of technical debt that you do when you just build a program with whichever paradigm where you add a new feature and then suddenly an old feature gets damaged or broken because you added a new feature that interferes somehow with old stuff. This doesn't happen in functional programming, which makes it pretty cool. Right. So to go on, maybe at this point you think it's kind of academic, which I wouldn't totally disagree with you, but also to point out to you, Microsoft, for example, created F#, which is a pretty functional language. And as Magnus said before, you can learn some more about F# if you want to win a ticket today. Also, Twitter uses Scala for its backend quite a lot. Scala is a functional, semi-functional programming language, so it's sort of half and half functional and other paradigms, but really it aims to make functional programming easy. So that's a cool thing. WhatsApp was written in Erlang, which is one of the most hardcore functional programming languages there are. And lots of it still is written in Erlang, especially the server-side stuff. Then Facebook uses Haskell, which is also one of the most hardcore functional programming languages to fight spam and malware, and they really swear by it. So, you know, I wouldn't mess with Facebook programmers regarding whether Haskell is great or not. They think it's great. And actually, going way back in history, Google was the search machine. Google was only possible really because of MapReduce, and MapReduce is a key algorithm which originated from functional programming. We'll come back to that one a little later on. And there are many, many, many more smaller projects and companies that are almost centered around functional programming, like Orderbeat, but also like many, many others. So that being said, I've talked about functional programming maybe in a way that almost highlights it as super amazing and super enormous, which it isn't. So I have here a chart from Stack Overflow trends, which shows you the difference of the object-oriented programming, and in blue, OOP, which so basically the amount of questions, the percentage of questions that were asked which had that tag versus functional programming. You can see pretty easily that functional programming is not even half, probably a third or so of what object-oriented gets. Now, there are more paradigms in programming than just object-oriented and functional, but object-oriented is like the leading one. So I'm picking up that. And it gets even more drastic when I put in the languages. So here I've just randomly kind of picked a few languages. Java is very object-oriented. You can do some functional and other types of programming with it, but it's very object-oriented. And as you can see, it's pretty huge, around 6% of all questions these days. And in comparison, I've listed two major functional languages here. They're just tiny, they're almost nothing in comparison. So functional programming, despite all its virtues and despite all its successes, is really still a niche thing. But it's gaining traction and it's getting more and more important. And actually those people who can do functional programming are, so far I know, very sought after in the market at the moment. Now, to compare functional programming to object-oriented programming, what we can see is that with object-oriented programming, that's what everybody learns at school. Everybody who does computer science, that is. And what you kind of learn is that objects are the basis of all software. So picture a class which contains students, and those students have attributes like marks, for example, grades. And then we have a function in that whole class, that object, which, for example, can calculate an average grade of that class. And so this is an object, this is a cornerstone of this software. And then you can manipulate different objects. You can have many classes that, or many groups of students, say that, make a year, and a group of years make a school, and a group of schools make I don't know what, and you can do lots of fun things with that. So it's kind of very modeled after the real world, and they contain, and this is crucial, they contain the data like students and grades and things, and functions like calculating averages. And so the focus of this whole thing is not anymore on what am I solving or what am I working on, because you've already defined that. You've already defined your students and how they work and their grades and what they are. Now you're focusing on how to manipulate this and how to make these objects interact. We all know this, I think. On the other hand, we've got functions that are, in functional programming, the basis of all software. So with this school and student example, we would have calculating an average would be a basis element, and then we'd have other functions like, I don't know, building a timetable or calculating the risk of an accident at a sports lesson, or whichever, you name it. Functions are the basis of all that. They are pure. I'll come to that later, what that means. They are deterministic. Deterministic means that they always give the same output, no matter which, I mean, if you put the same input in twice, they'll give the same output, no matter what. So like a random number generator isn't functional because it's not deterministic. And they're immutable. So that is like the type of a function. For example, if it returns a float, it will always return a float. It cannot return a string. And any type of data is immutable too. Like, it's immutable in terms of its type, and it's immutable in terms of what it is. So for example, the grades of students, if I want to modify one grade because I put it in the wrong way, then I have to recreate that whole data set and put it into a new piece of the memory. That can sound cumbersome, but it comes with its advantages too. And now the focus is on what do I solve? So we have the how-to, that's the functions. And now the question is, okay, I've got a bunch of functions. Which data do I apply that on? So in terms of the school, like which students are coming in this year, that kind of thing. So that's basically the difference between object-oriented and functional, which is kind of like they're almost opposite in a way, but you can make them work together as well. And key advantages of functional programming is that, first of all, everything is local. So you don't have data floating around somewhere in your code, and then you've got a student named Max somewhere in your code which you defined later because he came into the year later or something like that, and then you have to find in your code base, oh shit, where did I, sorry, nasty word, where did I put Max? No, I can't find him anymore, and where is his grades? No, in functional programming, everything is neatly separated. And so Max is together with the other students in a neat spreadsheet somewhere, and then the functions are somewhere else. And sure, you can do that with object-oriented in principle, but it's not automatic. And in functional, it is by default like that. It's timely. So, for example, if I gave a student the wrong grade at some point, now I corrected it, I know that I corrected it and kind of when. when in terms of the sequence of the actions I took, because I've kept copying that data and keeping stock of the versions of data because they're immutable. And so this way I'm sort of in a safer space because I don't manipulate my data at random and then at the end notice that there's a bug days after I've run this program, and now I'm thinking, oh, where was that? And do I have to rerun the whole thing again and to find the bug? With functional, that's a lot easier. And finally, I mean, it's more structured because everything's kind of neat, you know, everything is tidy. And so I think this tidiness is a key element of functional programming. So to go further into detail about what I mean by this tidiness, I could start with the lambda calculus. I decided not to go into detail of it because it's maths. And I'm not sure that everybody here likes it. But basically, what lambda calculus states is a theory of what you can actually compute, what you can actually put in a software program and what you can't, because you can't prove it. And the neat thing about this is it's the basis, first of all, of all functional programming, but it can be used to simulate any Turing machine. And just to drop some names, it was invented by Alonzo Church, who was the teacher of Alan Turing. So cool names in here. Functional programming, as I said, is based on this, but obviously you don't need to know all of this in order to be a good functional programmer. But it's cool to know that this is behind all of this. And I think, you know, basically you can say maths is tidy. So this kind of programming is kind of tidy sometimes, hopefully, mostly. Another key feature is side effects. And this is something that I talked about a little earlier. So consider this function, square. It returns the square of presumably a number. It's just some Python code. It's a very short and kind of dumb function that has no side effects. Now consider this function. This is a function that appends something, an element, to a list. And this has a side effect because I have a list here, which I have predefined. And so what happens is I cannot take this function, append to list, and like copy it and paste it into another piece of my software, for example, because it won't work. Because that global list isn't defined in that other piece of the function of the software. And what functional programming does, it eliminates all side effects. So in this example, we could put this list as an argument as well. And this is in principle what you do. If you have a side effect, you just add it as an argument to this function. This way, of course, it's a bit annoying if you're using the same list all the time, but you can solve that as well through higher order functions. I'll come to that in a minute. So to sum up, functions are pure. That means they've got no side effects. They are first class, and that's just another fancy word of saying they're the building blocks of a program. In object-oriented programming, objects are first class. And sometimes functions can be of higher order. So, I mean, they always can, but they not always are. Higher order functions, that means that a function can take another function as an argument, or it can return a function as a result. And so in this example earlier here, where you had appending to a list, say you're always appending to the same list, what you can do is you can define another function that takes the old function with an argument, which is this list that you're presumably using the whole time. And so this way you've killed a side effect. You've used a higher order function to make this program short nevertheless. Right, and one last key feature is, which is pretty cool, is the map reduce thing I talked about earlier. So consider the following example. not a very elaborate example. Basically, you have a list of integers, 1, 2, 3, 4, 5, 6. And what you're trying to do is you're taking only the odd integers, you're squaring them, and then you're adding all the squares. So you are doing 1 squared plus 3 squared plus 5 squared in this example. And what an entry-level software developer, let's say, would probably do is something like I've shown here. So they're writing loops, which is cool. But when this list of integers, for example, gets very large, this gets very slow. And so a more efficient way of doing it is using map and filter and reduce. As you can see here, it's all Python. And so you can use the filter function of Python to take out just the odd integers and then square it with a map, mapping the odd integers to their squares. And finally reducing, which is a fancy way of saying adding up in this case, but it can be just basically making a summary of whatever you're doing. And this, in fact, is something what like Google did back in the days. So which they're just still doing with their search machine, to be fair. So basically, their list is all web pages on the web. And what they're doing is they're filtering them. When you put in a query, then they will filter this whole enormous, vastly, impossibly large list by your query. Possibly do something else with it, because some pieces of queries may be more relevant than others. And Google knows this, so it learns kind of, okay, what's important and what isn't. So it might map something or another thing. And finally, reduce. So it'll show you a summary, usually of the best search results, and the reduction lies in rating these results and then finally displaying them to you. That's basically what Google does. And it was only possible because of the map and reduce algorithm. It wouldn't have been possible with a for loop, because it would have taken ages to scrape all these lists every time. So basically, Google wouldn't exist without functional programming, which is kind of neat to know. And finally, I mentioned there are no for loops. There are definitely no for loops and no while loops in functional programming. If you do want to loop, then you use recursions. And recursions means that you have functions which call themselves. So for example, here I have the Fibonacci sequence, which would be return. And you can see here that in the else statement, if I enter a number n which is larger than 1, then the function calls itself. And that's how it would loop around. If I say Fibonacci of 100, then you'll have to calculate for a while, but it's still more efficient than calculating it with a loop in most cases. The downside of this is that it uses a lot of memory, so you have to be careful with that. Okay, so now we'll get to the languages. I've just given you a brief overview here on the most boring slides ever on which languages are good for functional programming and which are not. I'll just go through them very quickly. So on this slide, you have languages which are not that great for functional programming. This includes Perl, which in fact is built on not being functional. So it makes side effects a key feature, because it started off as a text manipulation language. And when you're manipulating text, you really want to know, oh yeah, this thing that I did earlier right there, maybe change that around a little bit differently, that kind of query, which is always very local and not functional at all. So you don't want to use Perl as a functional programming language. You could use Go. Go is better in principle for other programming paradigms, but it's pretty straightforward to implement. I haven't done functional programming in Go myself, but apparently it works. In Java is okay, but it's not very readable, so stay away from it. Swift, you could do it, but according to my research, I mean, I didn't find anything about functional programming. Like, there's really just like 1 or 2 very small projects, and that's it. So if you do it, you'll be pretty alone. And in C, if you're one of those guys, so in C# and C++, you can in principle do some functional programming, but it will be impure, just based on how the language is built. And don't try to use Objective-C for this. Objective-C is procedural in principle, I believe. And so it just won't work. Next up, we have JavaScript, where, funnily enough, functional programming is quite possible. And in fact, if you use, for example, immutable data types, so that means you just specify the type and don't change it, like it's a float or an integer. That actually is good for like things like Angular and React. It gives them a performance boost, so that's great. PHP is also cool, not that bad, but you won't really do pure functional programming with it. Ruby is also not that bad. Scala is a notable one. Scala is mostly functional and only object-oriented if it's super complicated in functional programming. I'll come to that in a minute, what would be super complicated, but there are a few things, and Scala then just grabs the object-oriented option. Python is an interesting one. It didn't start out functional at all, but I use Python quite a lot, and so what I'm seeing is that in each update that Python brings, it gets more and more functional things, functional features, plus more and more packages are built in a functional style, let's say. So I find it pretty intuitive to at least do some impure functional programming in Python myself, which I do. And now we have basically the rock stars of functional programming. So there's Clojure, which we'll hear about later on. According to its creators, it's about 80% functional. So that's probably similar to Scala. It's possible to do less functional programming though in Clojure if you want to. Rust is an awesome language, which I personally adore. It isn't fully functional, but some of its key concepts are built directly on functional programming, and so it's useful to know some functional programming when you're starting out with Rust. And then we have Erlang and Haskell, which are both like some of the most pure functional languages that there are. I wouldn't recommend either of them for beginners, but if you're knee deep in the matter, then don't hesitate to give them a try. I personally haven't though. So what are the limitations? And we're almost nearing the end of this talk. The limitations of functional programming, but maybe also the beauty of that in itself. So one thing is that it's pretty difficult to have user-generated input or some random output with functional programming, because things are immutable, right? So if you have if you have a user input, that could be anything. That's mutable by definition. And if you have some randomly number generator, for example, which outputs a random number, that's also not functional. It could be something different anytime. It's not deterministic, so that won't work. There are, depending on the language, there are workarounds for these kind of things, but I found them to be extremely complicated. So in my opinion, if you're being pragmatic, it might be better to just go object-oriented or imperative or procedural when you do need that kind of stuff. Recursions, as I mentioned before, recursions can be quite heavy on the memory. So that can be a little bit uncomfortable if you're having a small computer. Again, there are workarounds for this kind of thing. And what I recommend is search for your specific problem. Usually there are some solutions on Stack Overflow or wherever you go. It's hard to give a general advice on those kind of problems, though, in my opinion. And then next up, it's not really beginner friendly, and I touched about that earlier. I mean, it's got strong mathematical foundations, which can be intimidating, which is why I left it out. And even if you're not doing any maths, the learning curve is pretty steep because it's just not at all what we're learning in school. However, the payoff is large, both on an intellectual level, I find, but also like if you're just searching for a job, because functional programming is on the rise, and we're seeing that the people who do functional programming are also better paid on average. That's a fact. You can look that up. For example, on the Stack Overflow, some nice statistics on that. Other sites too. And it's got a smaller community because it's small. But I wouldn't say that that's its total drawback, because you can probably see here at this conference, you just meet a lot of really nice people on the way. And when you have a community which is as crowded as, say, the Python community, for example, which is an amazing community, you don't meet that many people like as people. You meet them as, I don't know, I've got a problem with my code, can you please solve it, kind of thing. And so I find it quite nice to have a more intimate atmosphere sometimes, which is what functional programming at this moment in time is still pretty much useful for. So final words. In my opinion, and my opinion only, but I think it's not only my opinion, functional programming is extremely useful for large projects because it's clean, because you can put these functions into place wherever you go, and you know exactly what the function is inputting and what it's outputting. So you can just stack them together like Lego stones and build Lego houses. And this is especially practical if you're doing parallel programming, because sometimes with object-oriented programming and things like that, you can get speed issues when there are codependencies on different nodes. So that's a thing to watch out for, but not in functional. When you've got large data sets, unless you're doing a lot of manipulation and a lot of copy pasting, when you're using a lot of memory, you don't want that. Or when you need extensive testing, because in functional programming, testing it's not trivial, but it's as easy as it gets. Also, I would say, you know, even though it's just a steep learning curve, it's not necessary to learn from the books. Like nothing in programming, really. I mean, street smart beats book smart 100 times if you ask me. You can have a fancy degree, but that doesn't mean that you can actually code a cool project or write the software of a Tesla, for example. And functional programming is gaining traction. So we're seeing more and more mainstream languages. My eye is on Python because I use it a lot, but there's others too that are including more and more features which remind me strongly of functional programming, which is very encouraging. And also the communities of, for example, Rust, but also Haskell are growing. And you could probably see on this conference right here as well. So we have a growing, passionate community around a growing and passionate phenomenon in software. So that's it for me. I guess you like functional programming. If you haven't, then I hope you like it after this. So thank you for that.
Thank you, Rhea. Thank you very much for your presentation. Really,
you're welcome.
Really enjoyed it. I have some questions. What language did you start to work with? I mean, where did you learn to program?
That's a very interesting question, actually. I'm not exactly sure myself what I started with. I started coding sometime age 15 or something, just online browser based. And then what I really started out with was Bash and C++.
Did you
And
learn
now
it
I
by
use
yourself,
mainly
or
Python.
sorry, did you learn it by yourself, or did you have a class, or?
I didn't have a class. I learned it pretty much hands-on while doing science. So I was working on my bachelor thesis at the time on my first research paper, and I had to manipulate large amounts of data, which would have never, ever fit in 100 Excel sheets. So I had to ask some graduate students how they did it, and that's how I learned it, essentially. Very hands-on.
Cool. So then you started out with imperative programming in the beginning.
Right.
Was it hard then to go in from like, how do I do a loop to recursion? Or what was the biggest hurdle from going, from your perspective, going from imperative to a more functional style of programming?
So I would say it was probably from a research project before last, actually. I was, this will sound extremely technical, but I was working on trying to find out how precisely we know the data of particular collisions inside the particle collider. And I was working on, there were different sources of uncertainty on different types of data. And some of them were correlated and others weren't. And I was writing a software which would recognize which errors were correlated and then calculate a total uncertainty regarding those different error sources. So it was kind of a combination of physics knowledge, technical knowledge, and programming knowledge that got me there at the end. And I think these days I work a lot with machine learning algorithms actually and things like that, but which of course sounds amazing on paper, and it is, but actually I think my personal greatest achievement was actually this uncertainty thing, which didn't involve machine learning at all.
Cool. Final question. I mean, when you started working with functional programming, did it elevate your how you thought about problem solving, or how you attacked different problems?
It did. So for once, I found that I had a very similar trajectory now in programming as I had with physics. I started out as an experimental physicist and then moved to theory. And I'm kind of doing the same with programming. I started out super hands-on, and now I'm learning more and more about the theories behind it. That, and I think learning functional programming, I've written some code which is purely functional, but in my bigger projects, I've basically had improvements by using some snippets, if you want, of functional programming. By canceling some side effects and adding some immutability here and there, and that has actually sped up my programs by, I would say, more than 30%.
Cool. Yes, thank you very much.